My name is Savan. My teammate Tianyu and I present our project about VRChat guide, building integrated tasks and knowledge embodied agent in social virtual reality. So here is the agenda for the presentation. Social VR platforms allow users to interact in virtual spaces, enabling communication and collaboration as if they were physically together even from different locations. By merging physical and digital worlds, social VR is changing how we connect with each other. Over 171 million active users worldwide, and it has 34% yearly growth rate. Social VR is rapidly expanding. Almost one third of VR users engage with these platforms monthly. However, several challenges hinder the user experience. Through autoethnography and immersion studies, we have identified key pain points. One common issue is breaking immersion. Users frequently need to leave the app to find information, disrupting their experience. The lack of in-app information accesses creates onboarding friction, particularly for new users. Moreover, finding relevant and up-to-date information can be difficult as the tutorials are often generic and lack personalization. Immersion preservation is crucial for maintaining user engagement in social VR. Seamless access to information without breaking immersion ensures users stay fully present, enhancing their overall experience and even reducing motion sickness. Effective onboarding through personalized tutorials can significantly improve user retention. Addressing individual needs, it helps reduce friction, leading to a 50% drop in early stage abandonment in boosting engagement from a business impact perspective. Enhanced immersion and onboarding can result in a 23% increase in duration, higher satisfaction, and greater engagement. This ultimately drives revenue growth through VRChat Plus subscription and increased user loyalty. When I first used VRChat, I was guided on how to move and saw a board explaining how to add friends, but I was confused about the quick menu. So, does it mean like there is a regular menu also? Then I went to the avatar mirror and I realized I could only select preset avatars without any clear instruction on how to customizing my own. After trying VRChat, I had so many questions in my mind, which made me realize how important our project might be in improving the onboarding experience for users that have the same questions like me. So we explored the existing research to come up with a solution for this opportunity. Since we are dealing with an LLM-based agent for the onboarding in VR, we divided our focus into few specific directions, and here are the findings. So the first direction is onboarding in VR environments. The research has shown that user engagement on a VR platform is directly tied to onboarding quality. So it highlights the importance of onboarding. Also, poor onboarding leads to high drop-off rates. The research has shown that games have a low retention rate due to bad onboarding experiences. And then the existing research gives a conceptual framework for effective onboarding in VR, which describes some key characteristics for good onboarding experiences. And then we explored what has been done regarding LLM being used in social VR. So LLM enhances multimodal interactions in VR. For example, as a guide in museum tours, researchers has also focused on privacy concerns when LLMs are integrated into any XR platform. Since we need dynamic information access in VR, we explored real-time knowledge integration. So the research has given Dragon framework for dynamic retrieval during LLM responses. Existing research has also explored generating suggestion questions, meaning clarification requests in case of ambiguous user inputs to improve user interactions. And research has also shown how knowledge-based schema can handle queries in a conversation. And lastly, we want certain tasks to be executed during the onboarding by the agent. So research has also shown Genie worksheet framework, which has predefined policies that the agent can work on, and it can also handle the knowledge integration. So based on the literature that we have reviewed, we can observe some gaps and opportunities. The first one is lack of LLM agents as comprehensive guides in social VR. So the research has given us that LLMs can be used for museum tour guides, but the guide can perform certain predefined tasks only and lacks dynamic interaction capabilities. Second is limited exploration of multimodal interaction. So most of the LLMs interactions in the VR environments are text-based, whereas voice and visual cues can enhance the user engagement. And there is sparse research on personalized onboarding in social VR. So research has explored the importance of the effects of uh, onboarding in VR and also given us some frameworks for designing and onboarding, but personalized onboarding was not addressed. And there is inadequate focus on real-time information integration for dynamic VR environments. So research has given us frameworks like Dragon for dynamic retrieval, but those are not tailored for VR environments yet. So we focus on how can we design an immersive, real-time, context-aware, knowledge-integrated, and task-oriented LLM agent in social VR that provides personalization, meaning tailors interactions based on individual preferences, and that can perform dynamic knowledge retrieval, so it can retrieve and integrate up-to-date information from extensive data sources when needed. So what is our objective? We aim to build Genie worksheet based task management system powered by LLM and leverage the dynamic and personalized onboarding and recommendation. And we are focused on two use cases. The first one is onboarding, where the LLM agent will follow predefined procedures to welcome users and provide personalized onboarding tips. And the second is event recommendations, where it can recommend events based on the user preferences. Coming to the interaction design, the agent extends the greetings to the user to start a conversation. The agent focuses on exhibiting these key features. It manages context in the interaction, it personalizes responses, and it can fetch external knowledge if needed, and it can also handle context switches. For example, asking it to update your preferences instead of going forward with event recommendation. So here are some examples. When arrived, the agent greets user, then proceeds to get the user details and preferences, including user's experience level, device, and interaction style. And then it can go for providing onboarding tips or recommending events based on the preferences provided. Our agent system architecture include these core components: input processing, so it user interact interfaces for input collection; contextual semantic parsing, it has dialog manager which controls the conversation flow, and it has semantic parser which transforms the input into structured data. Then we have execution module. We track the user progress and data through this module. It has track tracker which tracks the user progresses and data. It has worksheet manager which manages active tasks. It has Genie worksheets. It is like an individual task handlers for each worksheet, and it has action executor. So it executes predefined actions plus API calls and queries through SQL. And then we have response generation module. It ensures responses are accurate and contextually appropriate, and we pass the output to agent which handles it through OSC chatbox and audio. During our implementation, we divided the process into three focus areas: core system foundation, which includes worksheet parsing, state tracking, and dialog flow; knowledge integration, which includes using SQL for database queries and Google Calendar API for fetching event data for recommendations; and then we have VRChat integration, which includes integrating action execution and response generation modules into VRChat through a general conversational agent, eLlama-T. While evaluating the agent, we focused on its task completion time, response latency, number of clarification needed in a conversation, and how it handles context switches, and also the query success rate. For user study, we adapted a comparative analysis of both web-based and VR interface for our agent to evaluate its usefulness in either form. We invited 10 participants within 22 to 30 years of age, and 6 of them were experienced with VRChat, and all of them had technical background. Each participant completed structured tasks of onboarding and getting an event recommendation in both interfaces while we measured performance and observed their interactions. For evaluating their experiences, we employed qualitative surveys with questions asking for numeric scoring, open-ended feedback, and interface comparisons. Our results shows impressive user engagement with 7 participants reporting smooth interactions and natural conversation flow. Users found onboarding tips useful, with 6 of them highlighting the safety features presented. 8 users found event recommendations relevant, with 6 of them confirmed their preferences alignment with the recommended events. Overall, 7 out of 10 would recommend using VRChat with our agent. During the evaluation, we gave the agent 13 generic queries about VRChat, 8 event researches, and 4 profile update. The agent achieved impressive 0.9% task completion and 90% query success rates. The response time for web interface was 6.3 seconds on average, while it increased to 10 seconds on average for VR due to text and speech conversations. The agent used 4.3 clarification per session for a given conversation, and it handled 1 to 3 context switches. In future, we would like to expand our user study to a large number of participants with varying VR experiences. We would also implement real-time social guidance throughout the user's journey in VRChat with an option to create or add an event to user's calendar dynamically. We would also address the current latency and optimize the performance of the agent in terms of response timings. And we could also add scalability to our system to handle multiple user conversations at a time. Thank you.